Hi everyone. So I just want to go over a quick few things on fractions and fraction operations. So let's just remember some things that we all should know about fractions as we enter Algebra 2. We should know that when adding and subtracting fractions, I need a common denominator. That means the denominator is the bottom of the fraction, and they need to be the same in order for you to add and subtract, okay? Add and subtract, okay? When we're multiplying fractions, you need to remember that you don't need a common denominator, but you should simplify before you multiply. Simplify before you multiply. And I'm going to show you examples of all of this, okay? All right, when dividing fractions, I want us all to remember that we must multiply by the reciprocal. So we switch to multiplication. We multiply by reciprocal. There we go. But a quick way to remember this, and you might have learned this in a younger grade, was to keep, change, and flip. And I'm going to show you exactly what I mean when we're dividing fractions, because this is the one that's the trickiest. All right, so let's look at some examples. So here I have adding fractions. So we're adding fractions. I need a common denominator. So I look at 5 and 12. The only number that I can see they have in common is 60. So I'm going to multiply this side by 12 over 12, this side by 5 over 5. I'm allowed to do that because that fraction I've just multiplied by is the number 1. And I'll get 48 over 60 plus 55 over 60. Now I add those together. And what's that going to give me? Like 103? Yeah, 103 over 60. All right, and that's perfectly fine to leave your answer like that, although I do want you to think about that for a second, where that would be represented on a number line. Okay, so again, adding, subtracting, need common denominator. Subtracting mixed numbers can sometimes be tricky. Now, you can do it two ways. You could turn them into improper fractions, or if the number to the left is bigger, then first you can subtract these numbers. So 2 minus 1 gives me 1. And then do 1/8 minus 1/5. Okay, now the 1/8 minus 1/5, you need to get a common denominator, which appears to be 40. So I'm going to multiply this side by 5 over 5 and this by 8 over 8. So I get 5/40 minus 8/40. And I have a problem here, don't I? Because I get negative 3 over 40. How do I do 1 and negative 3 over 40? Well, you have a couple things you could do. You could make 1 40 over 40 and a negative 3 over 40 and add them together and get 37 over 40. Okay? So that's one thing that you can kind of think about when you're doing subtracting of fractions. All right, multiplying fractions. Remember, I said you want to simplify before you multiply. You do not want to multiply these numbers. They're too big. So you can multiply diagonally and up and down, but you cannot simplify across. All right, so I see that 35 and 49 have a common factor of 7. So I'm going to divide each by 7, and I'll divide this by 7, I'll get 5. This by 7, I'll get 7. I also notice that 6 and 33 have a common factor of 3. So 3 goes into 6 2 times, 3 goes into 33 11 times. Then it's a little bit easier to multiply. Now I just multiply across and I get 55 over 21. All right, so if I'm going too fast, just pause and rewatch what I've said. But these are all operations we kind of expect you to know. All right, division. So when we're dividing, we have to be careful. We can't divide mixed numbers. So the first thing we'd need to do is we'd have to always make that an improper fraction. As a reminder to do that, we do 5 times 3 plus 3. So 5 times 3 is 15. 15 plus 3 gives me 18 over 5, divided by 2/3. All right. So now this is where we have to multiply by the reciprocal, but we have to multiply by the reciprocal of this. And so teachers often say keep, change, flip. So keep 18 over 5, change to multiplication, flip the one on the right. You can't flip 18 over 5. It has to be the 2/3. All right, then now we have multiplication, so we want to simplify before we multiply. So I see that 2 goes into 18, sorry about that, guys, 9 times, and then 9 times 3 is 27, 5 times 1 is 5. All right, so 27 over 5. Cooper. All right, now we've got, again, I'm switching around to subtraction. So 17 over 5 minus 2. All right, I need a common denominator. I'm going to write the 2 over 1. I'm going to multiply by 5 over 5 just to the left side. That's going to give me 17 over 5 minus 10 over 5, which is 7/5. Again, I could turn that into a mixed number if I wanted to, so 1 2/5. Or I could leave it as an improper fraction as 7/5. A few more, guys. All right, this is even trickier. So you got to remember that fraction bar means division. Okay, it means division. So I'm dividing fractions. So really what I have to first turn this into an improper fraction. So I'm going to do 3 times 5, which is 15, plus 2. So 17/3 divided by 4. All right, this means 17/3 divided by 4. So we change, we flip. So we keep 17/3, we change to multiplication, and we flip. 4 is really written over 1, so we flip it to 1/4. All right, then we would simplify if we could. We can't in this case, so we multiply. So 17 times 1 gives me 17. 3 times 4 gives me 12. So 17 over 12, or 1 5/12. All right, hopefully this is all coming back to you. All right, now this is a little bit trickier. This is fractions, subtracting fractions when the denominator is a variable. So we still need a common denominator. The common denominator in this case would be 4x. So we have to multiply this side by 4 over 4 and this side by x over x. All right, so on the right we've got to be careful because if I'm multiplying 4, 2 plus x is a quantity. So I have to multiply the 4 to both the 2 and the x, getting 8 plus 4x. And then 3 times x just gives me 3x. Now it's subtraction, so we got to be careful. So now we subtract the numerator. So 8 plus 4x minus 3x all over 4x. All right, now you notice in the top I can combine those like terms. So 4x minus 3x is just x. So I have 8 minus x over 4x. You may not simplify the x's or the 4 and the 8, okay, because it's an expression with addition and subtraction in the top. All right, last one. All right, 3 over y minus y plus 2 over 4. Again, I need a common denominator. So my common denominator is going to be 4y. So I'm going to multiply this by 4 over 4, and I'm going to multiply this by y over y. But I got to be really careful. Really careful here, because on the top I get 12, but over here I get y times y gives me y squared, and then 2 times y gives me plus 2y. Now notice I put it in parentheses. The reason I did that is because it's also being subtracted, so I actually have to subtract the entire quantity. So when I bring that together, and I add or subtract the numerators, that negative has to get subtracted to the y squared and distributed to the 2y as well. So it's going to become 12 minus y squared minus 2y. All right, and there are no like terms in that numerator, so I can leave that exactly as it is. I know it looks funny. Don't worry. Okay, last thing I want to talk about is absolute value. So first, absolute value is an operation in math, okay? So we want to make sure we know that it is the distance a number is from 0. Which means that if it's talking about the distance something is from 0, that it can only result in a positive. meaning the absolute value, and these are the symbols we use. They look like two bars, and we want them to be a little bit longer than the number, so we don't think that they're like an L. The absolute value of -2, that's asking how far is -2 from 0? Well, it would be 2 units away from 0. So we'd always take what's inside the absolute value and the output, so the equals can only equal a positive number. All right, so think about that if I say the absolute value of x is 5. That is actually asking me what number is 5 units away from 0. Okay, so here's 0. What number is 5 units away? Well, it's hard to determine. I could go 5 units this way and be at the number 5, or I could go 5 units this way and be at -5. So in this case, my x could equal 5 or -5. All right, so that's just a quick review of absolute value. We're going to spend some time on it during the Jumpstart class, but I wanted you to know the symbols and make sure you remembered it. If you're really into it and you want to investigate more absolute value, go to mathisfun /numbers /absolute value and learn more, okay? See you soon.